Welcome dear students. Let us start with the new topic of algebra, standard 10th, subject algebra, topic probability, module 1. Introduction. We use the following words to express the possibility in our daily conversations. The words are probable, maybe, impossible, sure, nearly, 50-50. Read the following statements regarding predictions, possibilities for the future. Most probably the rain will start from today. The inflation is likely to rise. It is impossible to defeat Indian cricket team in the next match. I will surely get first class. There is no possibility of polio infection if a child is given the polio vaccine in time. These are some words which shows regarding predictions or possibilities of future. Now let us see what actually a probability is. Coin is tossed before a cricket match. What are the possibilities of the outcomes? So we know that when a coin is tossed before a cricket match, either a heads will turn up or a tails. So there are two possibilities or two outcomes. Next example is a dice is thrown. What are the possibilities? So on the dice, on the face of the dice, there are total 6 types of dots. On one face, there is 1 dot. On another face, there are 2 dots. On the next face, there are 3 dots. On the next face, there are 4 dots. Similarly, there are 5 dots on other face and 6 dots on other face. So total, there are 6 possibilities. So these are the faces of dots or of the outcomes. As we can see, there are total 6 possibilities when a dice is thrown. What is random experiment? The experiment in which all possible results are known in advance, but none of them can be predicted with certainty, and there is equal possibility for each result, is known as random experiment. For example, tossing a coin, throwing a die, picking a card from a set of cards bearing numbers from 1 to 50, picking a card from the pack of well shuffled playing cards, etc. These are some examples of random experiment. Basically, random experiment is that in which we already know what are the outcomes, but we cannot predict that exactly that outcome might appear, because there is equal possibility for all the results. This is known as random experiment. Next is outcome. Result of random experiment is known as an outcome. For example, in a random experiment of tossing a coin, there are only 2 outcomes, either head or a tail. In a random experiment of throwing a die, there are 6 outcomes, according to the number of dots on the 6 faces of a die. 1 or 2 or 3 or 4 or 5 or 6. Next example, the third one, is in a random experiment of picking a card bearing numbers from 1 to 50. There are 50 outcomes. Fourth example of outcome. A card is drawn randomly from a pack of well shuffled playing cards. As we know, there are total 52 cards in a pack. Let us study about the cards with the help of the following diagram. So total there are 52 cards, out of which 26 are red cards and 26 are black cards. 26 red cards are further classified as 13 heart cards and 13 diamond cards, which are shown with the following diagram. And 26 black cards are again classified similarly in two types, out of which 13 are club cards and 13 are spade cards. In the pack of playing cards, there are 4 sets, namely heart, diamond, club and spade. In each set, there are 13 cards as king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 and ace. King, queen and jack are known as face cards. In each pack of cards, there are 4 cards of king, 4 cards of queen and 4 cards of jack. Thus, there are total 12 face cards. Next is the topic of equally likely outcomes. If a die is thrown, any of the numbers from 1, 2, 3, 4, 5, 6 may appear on the upper face. It means that each number is equally likely to occur. However, if a die is so formed that a particular face comes up most often, then that die is biased. In this case, the outcomes are not likely to occur equally. Here, we assume that objects that are used for random experiments are fair or unbiased. We do not use biased dies in this type of experiments. A given number of outcomes are said to be equally likely if none of them occurs in preference to others. For example, if a coin is tossed, possibilities of getting head or tail are equal. A die having numbers from 1 to 6 on its different faces is thrown. Check the possibilities of getting one of the numbers. Here all the outcomes are equally likely. Practice set 5.1. First question. How many possibilities are there in the following? Second question. Any day of a week is to be randomly selected. Answer. Total number of days in a week is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So there are total 7 days in a week. So if any day of a week is to be randomly selected, then there are total 7 possibilities because there are 7 days in a week. Next, third one. Select one card from the pack of 52 cards. Answer. Total number of cards is equal to 52. So total possibilities are 52. So the answer is 52. Fourth one number from 10 to 20 is written on each card. Select one card randomly. Answer. Total number of cards are 11. So the possibilities are 11. Next is the sample space. The set of all possible outcomes of a random experiment is called a sample space. It is denoted by S or a Greek letter omega. Each element of sample space is called a sample point. The number of elements in the set S is denoted by n of S. If n of S is finite, then the sample space is said to be finite sample space. This is the definition of sample space. Now, as we can see, there is a table where in the first column we have number, serial number. In the second column we have random experiment. In the third one we have a sample space, and in the fourth column you have number of sample points in S. So first random experiment is one coin is tossed. So sample space is S is equal to either H, T. So number of sample points in S is N of S is equal to 2. Second experiment, two coins are tossed. When two coins are tossed, the sample space becomes S is equal to HH, HT, TH, TT. So number of sample points in S is N of S is equal to 4. Third experiment is when three coins are tossed. So sample space is S is equal to HHH, HHT, HTH, THH, HTT, THT, TTH, TTT. Here H stands for head, T stands for tails. So number of sample points in S is N of S is equal to 8. Fourth experiment is a die is thrown. Sample space is S is equal to 1, 2, 3, 4, 5, 6. So number of sample points in S will become N of S is equal to 6. Fifth random experiment is two dice are thrown. So S is equal to 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So when two dice are thrown, number of sample points in S will become N of S is equal to 36. Sixth random experiment is a card is drawn from a pack bearing numbers from 1 to 25. So S is the sample space which is equal to 1, 2, 3, the number still 25. So N of S is the number of sample points in S is 25. Seventh random experiment is a card is drawn from a pack of well shuffled 52 playing cards. So sample space becomes diamond. Diamond cards are Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen and King. Cards of spade are Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen and King. Heart cards Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen and King. And the last is club cards Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen and King. So N of S, that is number of sample points in S, are 52. These are the examples of random experiment and they are sample points in the sample space. Let us see practice set 52. First question is, for each of the following experiments, write sample space S and number of sample points N of S. First one is one coin and one die are thrown simultaneously. Solution. Sample space S is equal to 1H, 1T, 2H, 2T, 3H, 3T, 4H 4T, 5H 5T and 6H 6T. So N of S is equal to 12. Hence, the required number of sample space is 12. S is the sample space and N of S is 12. Second one is two-digit numbers are formed using digits 2, 3 and 5 without repeating a digit. Solution: sample space S is 2, 3, 23, 2, 5, 25, 3, 2, 32, 3, 5, 35, 5, 2, 52 and 5, 3, 53. So N of S is 6. Hence, the required number of sample space is 6. The arrow is rotated and it stops randomly on a disc. Find out on which color it may stop. Solution: sample space S is equal to green, yellow, blue, orange, red and purple. These are the colors on the disc. So N of S is equal to 6. Hence the number of colors on which the arrow may stop is 6. Third one, in the month of March 2019, find the days on which the date is a multiple of 5. See the given page of a calendar. Here the page of calendar is shown. It is of the month March and the year 2019. We have to find out that days which are on the date on which day is the multiple of 5. The dates multiple of 5 are 5, 10, 15, 20, 25 and 30. From the calendar we can observe on these dates the days fall are Tuesday, Sunday, Friday, Wednesday, Monday and Saturday. That is, 5th date falls on Tuesday, 10th falls on Sunday, 15th falls on Friday, 20th falls on Wednesday, 25th falls on Monday and 30th falls on Saturday. So sample space is Tuesday, Sunday, Friday, Wednesday, Monday and Saturday. So therefore N of S is equal to 6. Therefore the total number of days on which the date is a multiple of 5 is 6. Fourth one, form a road safety committee of from two boys B1, B2 and two girls G1, G2. Complete the following activity to write the sample space. So A is a committee of two boys that we have to fill up. B, committee of two girls, again we have to fill up this. C is the committee of one boy and one girl, where one box is given as B1, G1. Remaining three boxes we have to fill up. Sample space R, that thing also we have to write. Solution: committee of two boys is equal to B1, B2. Committee of two girls is equal to G1, G2. Committee of one boy and one girl is equal to B1, G1, B1, G2, B2, G1 and B2, G2. Sample space is B1, B2, G1, G2, B1, G1, B1, G2, B2, G1 and B2, G2. Or N of S is equal to 6 because there are total 6 sample points in a sample space. So we have N of S is equal to 6. I hope you all like the video. Thank you.